Okay, so the problem from what I remember is there's like an inclined plane and it's frictionless, so it's going to accelerate for sure no matter what the slant is. And it starts from rest here and it covers a distance of 1 meter. We'll just make it straight here for our intents and purposes. So t equals 0 seconds and then t equals 1 second. And the distance covered here is 1 meter from here to here. Now, um, the best way to do this is if you're just doing it without an equation, you would say, how do I cover 1 meter if I start from rest? So my velocity here is 0. Here I don't know what it is, so this final speed, I don't know what it is, but I do know the time is 1 second. So how do I figure this out? Well, there is an average velocity equation that you could use. So average velocity equation says the final speed minus the initial speed, so VO or VI. If you minus those and divide by 2 and times it by time, that'll tell you how far something goes. Because what you're doing is you're figuring out the average velocity by figuring out the beginning and end and dividing by 2, assuming uniform acceleration, which these problems are, and timesing it by time, you'll get this. So knowing this, I could actually solve for the final velocity in this equation. You could also just, some people can do mental math and say, hey, how do I go 1 meter in 1 second? Because remember, this is 1 second. And they would say, well, I would go 1 meter per second, but it's under acceleration, so an average of 1 meter per second, which tells me that this is probably 2 meters per second, this is 0 meters per second, and on average I was in the middle at 1 meter per second. So my final speed was 2 meters per second. But to show the mathematics behind that, we can just solve for that where we go, hey, this is 1 meter, and I don't know my final speed, but I do know I started at 0 and 2, and this was 1 second. So if I do the math, VF equals 2 meters per second. That's the final speed right here. So that's the answer if they're looking for final speed. I don't remember if that's what's the end, if that's what they're looking for, because there's two ways they can ask this further if they want. So if they're asking for what is the final speed after 1 second, it's 2 meters per second. Um, I think yours had another second part or something. It said um, how far? Yeah, I think it said how far. How far was it going to go in the second second? So t equals 2 seconds. So in this next second, how far does it travel during this time? Well, the acceleration is 2 meters per second squared. How do we know that? Because it increased its speed from 0 to this speed in 1 second. Remember, it took 1 second from here to here. And so if you're increasing your speed by 2 meters per second in 1 second, that's your acceleration. And knowing my initial speed is this, I can actually calculate that out. There's equations that can do that. So you can calculate that out and say, um, I don't know if you remember the main kinematics equations, but there's x is equal to vi or vit plus 1/2 at squared. Let's see if this one will work. Let's see, I have time is 1 second, acceleration, I have that. I have my initial velocity and x, the displacement, that's what we're looking for. So this is a perfect equation. There's three other equations you can check and you might be able to derive it from two different ones, but this is going to be the easiest one. So we're looking for how far did it move, so the delta x or the displacement. And we know the initial speed is 2 meters per second, starting right here. Okay, and the time is only going to be 1 second plus 1/2. Acceleration is 2 meters per second squared. That's the acceleration. Time is 1 second because it's only 1 second. There's only 1 second from here to here. We're only talking about this time right here. And so we put 1 second here, and that's squared, remember, but it's 1, so it doesn't really matter. And so what do we get? We get 1/2 times 2 is 1. 1 squared is 1, so this is 1. And then we get 2 times 1, so that's 2. So the displacement is equal to 3. So the proper answer should be 3 meters on that particular problem. So this is the long way to do it. Some people can do a little bit of mental math and solve this, but that's exactly how you do it. So the correct answer, if you're looking for the final, if you're looking for acceleration, it's 2 meters per second squared. If you're looking for the final speed, the answer is 2 meters per second. So the final speed after that first second. And then if you're looking for how far will it travel over the next second right here, then that would be the displacement during that 1 second. Given that the starting speed is 2 meters per second, you're only dealing with 1 second of time, and the acceleration rate is constant the whole time because it's a constant slope. So we can figure out the displacement, and that's how you would do it.